Hello everyone. So this is a supplementary video on the math of VLSM. This is just to clarify your concepts even further. And I'll be showing both the methods here as well. So take a picture of this figure or topology, because we'll be needing that later as well a bit, just so when we draw the table. All right. So let's start. Now, looking at the topology, the very first task is to identify the network address, which is given here already. I'll just select the pen. Yeah. So this is our network address given. So we have that tick, and then we have a few LANs, like 5 LANs of 200 host, 30 host, 100 host, 120 host, and finally 500 host, right? Then there are 3 WAN links, which is this one, and this one, right? So these are all we have seen in the past, but there's a new thing, like these routers are all connected in with switches, right? This is not a WAN link nor a LAN, but this connects 3 routers, right? So this is a network as well. Now the specialty of this network is that there is no host requirements, correct? But as we know, each router interface, like these interfaces, need IP addresses. All right. So because there is no no host specifications given, and we can see that this switch connects these 3 routers, we can say that this network has 3 hosts. So this network has 3 hosts. Even if this was connected, this would have 4 hosts. All right. So that's the trick. Now, why did we connect all these 3? There is a switch in between, right? So it why not, and why these 2 are not being considered like 2 separately, right? So because unlike routers, switches don't divide networking domain. They switch all the all the ports that go from a single switch are in a single network, unlike routers. So in case of router, each node, each link, or each port is on a different network. But for a switch, for this single switch, all the ports that come out of this switch are on a single network. Hence, this whole thing is in a single network. And because they're in a single network and there are 3 routers, so we have to consider these 3 ports. All right, so 3 hosts. So we have one additional host requirement here. So I hope you have taken a picture, because I'll be changing the what do you call it, the window now, right? So I'll just go to the Wacom board now. Yeah, here. Anyway, so on this board, first we're going to draw the table that we need. So we had the hosts, something like this. I'll just write them in sorted manner right at the beginning. So these were the requirements. So I'll just, oops, sorry. All right. I don't know why. No, I can write. Anyway, so our host requirements, first we're going to give it a name. So ABCD, I'll just do that later. Then the host requirements, then the IPs, then give them how many IPs, host bits, and finally network bits, right? So we had a host of, first one to be the largest one is the 500, and there is the 200, and 120, 100, 30, 3, 2, 2, 2. Right? So let's name them A, B, E, F, G, I. Right? So for 500 IPs, they would need 502, because just adding 2 with the host requirement, 202, 122, 102, 32, 5, 4, 4, 4. And because they need 502 IP addresses, I'll have to give them 512. The immediate larger than the 502 to the power something is 512. This guy needs 256. This guy needs 256 as well. Oh no, this needs 128. This needs 128. This needs 32, 8, 4, 4, 4. Right? So to represent 512 bits, I need 9 bits. This needs 8, this 7, 7, 5, 3, 2, 2. And because their host bit is 9, their network bit would be 32 minus 9 is 23, right? Yeah, 23, 24. This is 25, 25, sorry, 27. It is 27, right? Yeah, 29, 30, 30, and 30. And this is what we need, the table. So hope you have taken a picture of this table as well, because I'll be moving this away also. All right, so I'll just rub it. I have this table on my copy, so I don't need the table, but you guys would be needing that. So yeah, go back and take a picture or something before you start. So we had this IP address given, the network address given was 10.13.0.0 slash 20, right? Now we are going to start the math soon. So let's bring in the binary calculation display capture thingy, right? I hope you guys can see that. Now let's start. So we have this thing already, the network address, and we have to start breaking this into the subnets, right? We have to apply VLSM again and again. Now the IPs we have, that subnet mask is 20. So 10.13 doesn't need to be broken into binary, because the first two octets have 16 bits in them, but our subnet mask is 20. So the 20 intercepts the third octet. So we have to start breaking the third octet. And why is that? Because up till this point, the cursor, as you can see, this many bits, oops. So here we have 20 bits, right? So the first, these are 8 bits. Up to this, it's 16, 17, 18, 19, 20, right? And so this part is our network bits. So I'll just highlight that red because we cannot touch it. I'll just mark it red. Oh, what happened? I'll mark it red, right? And we have even further for fourth octet. So this is what we have to work with. These bits are in our disposable. The last, what do you call it? 8, the last 12 bits, right? Okay, so we have this whole thing as host right now, but we have to see how many actually we need. So looking at the largest host requirement, it's 500 size, right? So 512. So because it's 512, we need 9 bits for the host. So speaking of 9 bits, from the right side, we need this many bits, right? So the 9 bits from the right hand side, I'll just highlight them green because this will be our host bit. So the remaining 3 bits, these 3 bits are our subnet ID. So how many subnets can we make from here? What do you think? So 2 to the power 3, we have 3 bits, so 2 to the power 3, it's 8 bits, right? So we can have like 1, then the next combination would be 1 0, the next combination would be 1 1, and you get the idea. It's then it keeps on going on till 1 1 1. So first we're going to work with the first line, this one, right? So these will be coming later anyway. All right, so I have another thing with me. So the other tree, the smaller tree, so we have a total of 12 bits to work with, right? So 2 to the power 12. What is 2 to the power 12? 2 to the power is 512. Wait. Anyway, so 2 to the power 12, we can divide it into 8 times. 512 is 4096, right? So this equals to 4096. Correct me if I'm wrong. 9 is 512, so 10 is 1000, 11 is 2000, and 12 is 4000. Yeah, it's 4096, 4096. So with 4096, the largest requirement is 512 hosts, right? So I have to start breaking it into 512. Now, guess how many 512s can I have with this? I can have 8 512s, right? Also, the 3 subnet bits that I had here on the top right corner screen, if you see, we have 3 bits, and with 3 bits, we can make 8 combinations, right? So we can have 8 blocks of 512. So like usual, I'm going to mark these, like this is A, so this is A as well. And from A, I'm going to bring out the first combination. So this is B, right? So I'm bringing out B from here. So, and the first combination from the top right corner, as you can see, it's all zeros. So 10, 13, and 0.0. So 10.13.0.0. Now for 512, the subnet mask, we are needing only 9 bits, right? So all the others are of subnet of the network bits. So that's 23, and I'll give it to A, right? I have no idea why that's happening. Wait, into shape. All right, I have that removed. For some reason I cannot rub that off. Anyway, so A, so this one is used up. I cannot use this anymore, right? So I have to go to the next combination of 512. So let's go to this one and name it C, and C has been extended from A, so I'll just extend this one. So 10.13. Let's see what the next combination is. So as you can see, from the next combination, the third octet, the combination of third octet is this one. So 6 zeros and 1 0. That's 10.13.2. The last octet is still all zeros, so 0, and its size is still 512. So /23. Now I have this whole big block, but if you notice, I don't need 512 anymore. The next client wants 256 hosts. So I'll break this down, right? So once I started to break it down, this will have 256s possibly. So from C, I'll be using this one first. So let's name it D. It's C. So C was extended from D. So I'll do that same here. C is extended from D. And I'm sorry, D is extended from C. And the IP address would be, let's see what the IP address is. Now we are breaking down this, right? So on the IP table, let's rub this off and continue with that one. So we are working with this network. So this is our main network. Let's keep it right there like that. And now because I'm under that, I'll have to mark this red as well, right? So I have to work with the remaining bits. Now to work with 256 bits, I need 256 hosts, I need 8 bits. So this bit would be basically no color, right? This is our subnet mask, and as you can see, this can be either 0 or 1. So this can be either 0 or 1, and now we are going to first work with this one, right? So the first one, D, so the combination wise, the IP would be 10.13.2.0, and 256 requires 8 bits, so 24 is the subnet mask. So I am using this combination on the second line, this one, right? Okay, so let's see. I have a block of 256 and the client needs 256, so I'll give this to B, and it's given to B, and then I have another 256. I'll name it E. So I have E, and E was extended from C, so I'll just bring it from here. So 10.13 dots. So let's see what happens on the third line. So we have used this up. I'll just strike through. I forgot to strike through the first one. No, this won't be striking through yet. Anyway, so yeah, so let's see. Oh, this would be strike through. I have already used that as well, right? Anyway, so this is used, and seeing this one, as you can see, the combination is now 10.13.6 zeros and double ones, and 6 0 double ones convert to 3 dot. 0, and it's of size 256, so the subnet mask will be 24. Now I have 256 with me, but as you can see, the next line is asking for 128 IP addresses, so I'll be breaking this again. This is like just repeating the same step again and again, right? So I have the first 128 to work with, and I'll name this with F. So I'll extend E and I'll name it F, and 10.13 dot something will happen here, right? Now going to the IP address here, I have this whole block, but I'm not using this whole block, right? So I'm going to, like, since I'm under this block, this is taken as, I'm sorry, this is in the network part as well, and to represent 128 bits I need 7 bits only. So this 7 bits would be still green, but the 8 bit here will go back to being white because it's a subnet mask, right? So I have these two combinations. It can be either 0 or 1, right? So I'll first work with this one because always we go serially. So going with this one, it's this combination, right? So 3.0 and 128 has a subnet mask of 25, so there you go. And I'll give this to C. All right, so I gave this to C, so this is used up. I'm sorry, I forgot to cut. And then this is used up, as I have just said. So I'll just put a strike through here. All right, and then we're going to go to the next combination, which is this one, right? So here, this basically means I'm using this one, so let's name it G. So G is coming out of E, so here you have G, and 10.13. The combination suggests that the last part will be 128. So yeah, this is it. So the third octet was 3, and the last octet is 1 and 7 zeros, that converts to 128. All right, and if you notice, client D is asking for 128 as well, so I'll give this to D, and I have used up this 128. Now interestingly, I'll let you decide what will happen to the next part. Will we be extending more from E or from some other route? Right, so as you can see in the last part here, right here, right, this was a total block of 256, and from this whole block of 256 I extended two 128s. Now two 128 means 256, right? So the moment I use, so it's like you bought a KitKat which has a total of 256, what do you call it, 256 KitKats, right? But you have divided into two and given 128 to each, and now both of them finish the 128 KitKats you have given them. This means this whole box has ended, right? So basically this means that you have exhausted this block. If you look at the top right, we have used up this one, right? And if I go even top, now this 256 that I just crossed out, this 256, right, came from the above 512. Now the same concept, you had a kit packet of 512 KitKats, you gave it to two people, 256 each, and both of them has used up those 256 KitKats, right? So totally 256, total 512 KitKat is finished. So you are done with this 512 as well. This block is exhausted as well, right? So you have no more blocks available among these first two. Now which block do I actually have? So from 4096 I have used only 512 twice. That means out of 4096 I have used up 1024 IP addresses. So I'm going to go to the third block of 512 IPs. So let's name it G, and this would be H, right? So an H was extended from A. So this was the tricky part here, right? So going back to A, now notice, notice if, I'll show that later a bit. So H is from A. So basically from A, there will be a third thing, which is 10.13 13 dot something. Now let's see what that something is. Now we have exhausted this as well, right? This is exhausted, and these were under that subnet, so I'll just rub them off. And the next combination that's possible is basically 1 0, right? So I'll just remove the strike through from here, right? So this is our new block. So 10.13.0 I'm sorry, 6 zeros and sorry, 5 zeros, 1 and then 2 zeros, and that translates to 4.0/23. So I have a whole new block of 512 IP addresses. But what do our next client want? They want only 32 IP addresses. So I'll break this to sizes of 32. All right, as many as I need. So I'll just bring it down here. So why I brought this down all the way down, because if you notice this line, all of the blocks here is of size 512. All the IPs of this line is of 256. All the blocks of this line is of 128, and all the blocks of this line would be of size 32. Okay, so from the combination wise, the first one would be all zeros, right? So just what the root is. So 10.13.4.0, we have this, and the combination, the subnet mask for 32 is 27, and 32 block, it goes to the 32 block itself. So E gets this, and we have used this up. So H, this is I'm sorry, I forgot to mark that, and I have used this up. Now going to the next one. So because we're dividing these, so now what will happen is this is basically all red, because these are all the what do you call it, all of the same subnet of 10.13.4.0. we are under 10.13.4.0, so we cannot change the subnet mask of that block, right? And for our new subnet, this is it. So to represent 32 blocks, I have these 5 blocks, 5 bits given away here, and I have 4 blocks with my hand. So I have used up the first combination, and the second combination would be, this would be 1 here, and if this is 1, the IP address, so I have used this up for just now, this is of size 32. So here this combination translates to 10.13.4.32. all right, so this is the second one, and this is of course J. What did I just do? This is J. I'll name it J here as well. All right, and this is a block size 32, but as you can see, our next line needs only 8, so I'll be breaking down this even further. So I'll break this down to 8s because I need 8s now. So this is 8 IJK, this is 27. So from J there will be a K now, right? So because I'm breaking down this whole thing, this part, so I have to work only with this, and all the others would be now red because it's part of the bigger network. So this is all red, and I have this, and because the host size is 8, I need only these 3 bits. So actually this would be grayed out, right? So I have this too, and with 2 combinations I can create 4 subnets, right? So if you notice, 4 into 8 is 32. So the first combination says that it's 10.13.4.32, and because this line is of 8, this would be 29, and I'll give it to F. So I have used this up, and then I'll go to this one. So this is L, and I'll just bring it out and change the combination on our main calculation place. So this would be used up, and this is our IP now, so I have to change this one. So the combination suggests this is 10 dot 13 dot 4 dot 40 slash 29, but our next client wants only 4 IP addresses, so I have to break this down to 4, and so this is M. Now let me just scroll up a bit. Yeah, so okay, so let's see. So I need a size of 4 here, so I'll just take it out and just do that here again. So 10.13 dot, let's see what our combinations say. So because I'm breaking the 8 this subnet, so this is going to be red now. Let's just bring that down here, and this is red now. Where is it? Here. And to represent 4 we need just 2 bits, so this would be white now, right? So our first combination is this one. Let's see. So this combination suggests the IP address is 10.13.4.40 slash 30, and I'll give this to G. So this is used up. And oh, I forgot number J, K, L, M. So M, and then there is N now, which is this one, N. So 10.13.4. Let's see what the next combination is. So I just used this one up, the first block of 4, and oh, let me just copy this first. This would be 1 now, and I have used this up. So the second combination suggests that the IP address would be 4.44, and I'll give this to GH, right? Now I have used this up. Now notice I cannot have any combinations out of this anymore, right? So this is crossed out, and the moment I cross this out, this whole block is crossed out, right? Why? Because from the tree, see, this was brought out from an 8, so 8 had two childs, 4 and 4. 4 plus 4 is 8, and I have used both, so this is exhausted, right? I cannot use this anymore. But what can I do is that this 32, I had a pack of 32 and broke down into 8s, right? So 2 8s ended, like 8 plus 8, 16 of them are used up, but I still have more 2 8s, so I'll bring out the third 8 host. So N, this is O. So this was brought out from the 32 size blocks. So here from J, right? Yeah, from J. So from J, I'll create another block here. So that's 10.13.4. Let's see what the combination suggests. Oh, where did that go? Oh, I'm sorry. I accidentally cut way too more. So I have used up the combination 0, 1, but now I have the combination 1, 0 with me, right? So 0, 1 was exhausted. Now I have 1, 0. So that translates to 48 slash 29. All right. So 32 plus 16 is 48. And I have a block of 8, but I don't need this. So this was O. So I'll be creating a 4 from here. I can create 2 4s, but I'll just create the first one first. So or P. So name this P because O came out, sorry, P came out from O. So there you go. So 10.13.4.48 slash 30 again, slash 30 here as well. And this is of size 4, and this will go to I. And there you go. The whole thing is done. All right. So this was the first method of doing the whole math. Thank you. Anyway, this took half an hour to complete because I was like going very slowly so that you guys understand and whatnot, but this is not exactly so lengthy. See ya.